Hi, my name is Master Chief Potter, and I'm retired from the Navy as an electronics technician, and I would like to explain the casualty evacuation concept. And first, I want to talk about what the operational problem is that we're trying to solve. In this case, we have a large number of wounded people that require casualty evacuation from the injury site to a medical treatment facility. And the challenge is that the number of wounded and their state is dynamic. So you have this dynamic state here, and you have, based on the ships moving, the medical treatment facility range and the number of beds here, and then skills they have available are also dynamic. So you're basically trying to figure out what's the best mix of which patients should go to what medical treatment facility. And to complicate that problem, you have a transportation problem involving aircraft at sea. And the aircraft are dual purpose. They're not solely for transporting wounded. They're primarily there for other reasons, like warfare missions like hunting submarines, or for logistics. So we have this dynamic challenge here also. So the problem is, if you have a constantly changing or a rapidly changing state of wounded people and the number of wounded, and you have a dynamic geographic place and skills and beds available for medical treatment facility, and you have a dynamic number of transports you can use to get people off the battlefield or off the injury site, you have this problem can be so complex if this number of wounded increases enough that it's almost impossible for a human to make the most optimal mapping, or what we call a slate. So a sortie slate is a list of injured people on a particular flight for a particular aircraft going from a evacuation area to the medical treatment facility. And what we can do with algorithms is we can look at an optimization algorithm that says, if these are your objectives, we have an objective of either low or high mission risk, depending on the mission. For a training mission, we'd say I can accept high risk. You have risk to patients that are allowable. If you're hunting submarines and you can't pull off an aircraft, you're going to have higher patient risk. And so you can layer in these objectives, and then the solver will solve a slate. And that looks like this. I'm going to close this down real quick, and I'm going to run this model, and as you see, a slate appears here that automatically and dynamically updates this slate. Now, why does it have to be dynamic? And the answer is, this is just using the patients as an example, is if each one of these are patients, and where I'm at today, let me copy this real quick. Where we're at today, or right now, is this time here. All these patients are survivable. But if we look over the amount of time it'd take to evacuate them and get them to a medical treatment facility, this patient here, the odds that they would survive are very poor. If there is only room for 3 people or 2 people, who do you take? And the answer is, you probably take the people that have the best chance of survival as number 1, and possibly one of these is number 2. This particular patient we can hook to an automated critical care system, which is another Office of Naval Research project. So that is the idea of a slating algorithm. We call this the CASSM model, or a computer-aided sortie slating model. And this concept would be a 5-year project at the Office of Naval Research to build the algorithm and then build these dynamic predictive models that predict the states of these different components that go into the model. That's it. If you have any more questions, please contact whoever sent you this video. Thank you.